So hi everyone, good to see you virtually. I hope everyone is staying safe, and we'll see how this goes. I've never actually given a talk on what I think the frontier is. I'll speak for about 15 minutes, 20 minutes, hopefully no more than that, and then open up to questions. Let me make sure I time myself. And today's talk is going to be very high level. It's not a technical talk, although, if you want resources, I'm happy to point you to that. But today's really a very high level talk. Everyone is welcome to, hopefully it's accessible to everyone. All right, so a little bit about me. So I am a professor at USC, the University of Southern California. But I think beyond USC, what I like to say is my projects define me. So I'm very proud of all my projects, everyone who works on my projects, everyone I collaborate with, all my students, all my partners in all of these projects. They're all multi-partner projects. And here are just 6 of them. Almost all involve knowledge graphs, some a little bit unusually, and not in a very traditional way. Others are much more traditional. So there's e-commerce, where we work a lot with industry partners. I'll say a little bit about that, but not too much. There are AI for social good projects that I'm very involved in. Human trafficking is a big one, but also crisis response. AI networks and society is one where knowledge graphs are less traditionally used. It starts intersecting with network science, actually, and that's a very interesting way to think about knowledge graphs. And then some of the others are more moonshot projects, and I think are really relevant to the frontier. So the common sense reasoning is one project where we're trying to get AI to actually have common sense, which is a very hard problem, and is very related to the frontier that we hope knowledge graphs can conquer eventually. So let's get started with just what is a knowledge graph. Now, this may seem redundant because you're in a conference that is named after knowledge graphs, and I believe we are now in the 3rd day of the conference. So, you must have seen a lot on knowledge graphs. But I like to give 2 definitions, just so we are on the same page. Now, one definition is the more intuitive one, which is that a knowledge graph is a set of entities, relations, and attributes, that are linked together in the way that you see over here, represented as a graph. But the key thing is what is in the graph. So it's entities, relations, and attributes. Entities like Bob Dylan, Steve Jobs, relations like lives in, was born in, and attributes like Robert, the male, what we would call in the semantic web community as literals. And it can contain a lot more than that, but these are usually the things that most knowledge graphs contain. Now, there is a second definition that is much more technical, and it's one that you may not have heard before. So I want to make sure I give it to you, which is that a knowledge graph is a directed, labeled, multi-relational graph with semantics. So I'll repeat that. A knowledge graph is a directed, you can see there are directions, labeled, there are labels on pretty much everything, multi-relational, because the edge labels are usually, there's more than one. In fact, there's usually more than 5 or 10 even. So in that sense, it's very different from a social network where you just have 1 or 2 relations, like friends or LinkedIn connection or whatever it is, but there's only 1 or 2 relations in most social networks. In a knowledge graph, you have many, many relations usually. And it's got semantics. The labels can't be arbitrary. They're not things that don't make sense, but there is something in the knowledge graph, and that's the knowledge in the knowledge graph, that makes it amenable to some model of semantics. And I'll say a little bit about what we mean by semantics. It's a complicated issue, the notion of semantics. So that's the definition, 2 definitions, one intuitive, one more technical. I prefer the intuitive one, but you're free to go with the technical one as well. Now, why use KGs? I like to give a very simple answer to this question. I think there are people who give very complicated answers to this question, where they try to find, I think they are trying to answer the question, what are the applications of KGs? I think that is a different question. The question I want to address is, why do we have knowledge graphs to begin with? And it's, in order to answer that, we should first see, what if we didn't have knowledge graphs, right? So what else is there? And there's a broad spectrum of things, so I'm only showing two extremes. One of the extremes is natural language, right? So this is something that is very good for humans. So human readability is very high for this, where, you just read it, you don't need, most people can read and write, right? So you can just read this and it makes sense to you. You don't have to think about the meaning of every word. You don't have to parse the grammar. It's just happening very naturally in your brain, something we don't appreciate often enough, but there's no other animal in the animal kingdom that can do it, and we can. So, there's human readability. So this is natural language. And then on the left-hand side, you have this kind of very highly structured data set, with a very formal schema, whether that's a relational database model or some other schema, but there's usually a very formal schema where everything is prescribed. So usually these are tables, and these things you see in here, it's very small, but this is a company model. So you have categories, suppliers, order details, customers, and you have things like product ID, product name, category ID. So there's a lot of very formal semantics on the left-hand side, whereas on the right-hand side, you have very informal semantics. It's not really clear what the semantics are. How do we understand why we understand this kind of document? It's actually a very complicated problem, believe it or not. Philosophers have grappled with it over the centuries. Cognitive scientists, there's an entire field in cognitive science and psychology that looks at language, that why are we able to understand language and work with language in the way that we do. Now, knowledge graphs actually fall in the middle, and I think that's what makes them very attractive, because on the one hand, we don't need the kind of structure that we have on the left-hand side, so we can have very semi-structured kind of data, which is incomplete. There are some things are defined, other things are not defined, but at the same time, there is something about the knowledge graph that is very natural. Like when you look at this knowledge graph, right, it's kind of, again, you don't have to think about it as much as you would for this table. So Bob Dylan created a song, and Bob Dylan was born in the US, and these are fairly intuitive facts that you see in the knowledge graph. So I like to think that the ideal knowledge graph tries to capture the best of both worlds. And this also leads us to why the frontier problem is there. What makes a knowledge graph challenging, and what are the frontier problems in trying to achieve the perfect balance between these two? All right, so have you seen it before? I think you have, probably many times. But again, just to be complete, I'm sure everyone has seen it, because you must have typed something in Google that brings up something like this, right? And all of these things that you see over here. So this thing on the right-hand side is a knowledge panel. It comes from the Google Knowledge Graph. The thing on the top, where you see the actual things to do in San Jose, which is a query, is also coming from the knowledge graph, but it's linked to multimodal data, right? So there are images, there's the map, right, which is also multimodal. You have other things that people have searched for. You have things which have been derived from Wikipedia. You have things that are coming from third-party providers, right, the hotel rates and so on. So there's a lot of complicated things happening when you type in the query, but we should not lose track of the one thing which makes all of this possible, which is that Google and the companies that use knowledge graphs for these kinds of problems have recognized that San Jose is an entity. It's a thing. It's not just a set of characters. It's not just a string, which is what it used to be once upon a time, but it's actually a thing. Google can recognize that San Jose corresponds to an entity in the real world, which is in its knowledge graph. But it goes much further. What it can also see is that the phrase places to visit is a class of things. So that also it's able to recognize that this doesn't correspond to one thing, but this is the query. So there's a class of things, which is the places to visit, and it's qualified by San Jose, it's linked by San Jose, but that's really what the user is asking for. The user is asking for a set of things, and it's qualified by this other thing, which is San Jose. So it's actually quite sophisticated, the way that it arrives at something like this. And beyond Google, there are enormous use cases today. So this is sort of the application slide, that who's using the knowledge graphs and why. Again, I'm sure you are very familiar with this, but I do want to actually say what is going on right now so that we can think about the future, the frontier. So in the non-profit, you have the Wikidata, which is a kind of almost like an open source Google Knowledge Graph, although there's not a direct connection between them. But if you ever needed something that looked like an open source Google Knowledge Graph, then this is the closest, I think, that would come to it. It's a very big crowdsourced knowledge graph that contains a lot of different things. There are links to Wikipedia, to other knowledge graphs. This is an amazing data set, and it's growing. Microsoft bought LinkedIn, and both of them had knowledge graphs or knowledge graph-like technology even before the acquisition. But certainly they are very active in knowledge graphs today as well. Especially the LinkedIn graph is quite sophisticated. It's not like a normal social network, right? It has lots of things in it now. Skills, your connections on LinkedIn, the groups you belong to. In general, social media has become very sophisticated. And all the big social media companies have something that looks like a knowledge graph under the hood. Amazon has been very actively promoting the product graph, in many conferences. I think this is an amazing thing for e-commerce. It has really made other people in e-commerce sit up and take notice, which I think is very good. And the team is extremely well qualified, very well-known researchers. They have done really amazing work. Some of the researchers had worked in Google before. So, there's a lot of cross-cutting innovation that has happened over the years. And even Uber, this is a snippet that I saw in one of the presentations. I haven't seen too much on it, except that it exists. So we'll have to wait and see to see what happens and how it uses it. But I was very encouraged to actually see that even Uber and, companies that you wouldn't associate very strongly with web data or, a very heterogeneous data, such as what Amazon and LinkedIn and Wikidata and Google and all these companies have, even they are investing in knowledge graphs. And of course, there are the healthcare companies, there are other companies, they are all trying to invest in knowledge graphs right now. So it's a golden era, I think. All right, so now I want to start getting into the frontier, now that we have that background in place. And what I'm showing you here is some of you have probably recognized it, some others may not have seen it, although you've likely heard of it, which is the Gartner's curve for emerging technology. So Gartner publishes this for several different things. There's emerging technologies. I believe there's one for strategic technology, something like that. This one is for emerging technologies. So they specifically look at technologies that are more cutting edge than others. And as not very long ago in 2018, we saw knowledge graphs enter into the picture. I think before then, I don't recall seeing it. Maybe it did show up, but I certainly do not recall the phrase knowledge graphs showing up before 2018. But if it did, then I'm sure it must have been in this early phase also. So according to Gartner in 2018, knowledge graphs was, on the innovation trigger. It was, hadn't even approached the peak of inflated expectations yet, which is in itself interesting because the Google knowledge graph was, first publicized in 2011. So this was 7 years after the Google knowledge graph. And it's still kind of just climbing up towards the peak of inflated expectations. So it may even have been a little bit late, I think, in coming to this curve. And maybe one reason why it started happening in 2018 is because some of the NLP and some of the deep learning tools needed to mature a little bit before we realized the full potential of knowledge graphs, and we needed to see what Google was doing, what Amazon was doing, what big companies are doing, so that we can sort of learn from the giants in a way, because they are investing a lot into these technologies. So finally in 2018, we do see knowledge graphs come up. Now what happens in 2019? Knowledge graphs climbs a little bit up, right? So that's good news, I guess. We also see graph analytics, which has, kind of very suddenly in a way, because you don't see graph analytics anywhere over here. I mean, in this 2018 curve, we're not seeing, there's nothing here about graph analytics, right? But then in 2019, we see graph analytics, and somehow it has gone all the way, it has managed to bypass, this entire first portion of the curve, and it's already in the peak of inflated expectations. But I think that the two have to be thought about together. I think what was happening was that because of Neo4j and some of the other graph databases, they sort of came up, and they are closely tied to knowledge graphs, but they're also databases, right? So it's not just for knowledge graphs. You can put any graph into some of these infrastructures. And I think that within a year, the graph analytics really did go through this amazing journey where it was just able to come to this path because of heavy involvement from industry in this. But knowledge graphs is climbing up slowly and steadily. So now we come to 2020, right? This is where we are now. So what do we see? And now again, something really interesting has happened, which is that, once more, now we're seeing ontologies and graphs. And so we're not seeing graph analytics, we're not seeing knowledge graphs, but we're seeing ontologies and graphs. And it's like, these two things got combined and then they slid down a little bit more. And then now we're here, right? So it's kind of confusing, I think, a little bit, right? Which is that, what's happening here? How can something go in just 3 years? First here, then there, then a little bit down, a little bit up. We don't know what will happen this year. Will it even show up? Is it now on the plateau of productivity? We don't know. So it's kind of an interesting, it seems like the consulting companies can't really make up their minds on this, is how I think about it. And it really depends on what they are looking at, what applications they are looking at, who they're talking to. It's really not clear, because you can ask some other people and they would tell you that it's on the plateau of productivity, that it's already crossed a hype cycle, and it might even have crossed a hype cycle as early as 2017 or 2018, and that now it's actually on the plateau of productivity. So, take this with a grain of salt. I mean, basically, if you see this again next year, we will see another curve like it next year, not too far from today. We don't know where it might show up, and it might disappear from the curve altogether. So I think we have to take this with a grain of salt. But the encouraging thing about this is that it does seem to be progressing, right? I mean, that is the one thing that we see over here, that it is progressing. It started from the innovation trigger, then, kind of went up, fluctuated, and is now sort of coming down. And, we are really at a time when this is starting to become very mature. And we are seeing a lot of applications and a lot of people involved in this, and a lot of companies offering products, and a lot of companies developing their own knowledge graphs and knowledge graph technologies under the hood, behind the scenes. So there's a lot going on. And the other thing I want to point out very briefly is that knowledge graphs are really not that new. This is something that is not surprising to anyone who has been in AI or NLP for a while. In fact, you go back to the 1991 or even before, and there were these conferences, the Message Understanding Conference, which was a DARPA-funded conference. And these were trying to construct what they called knowledge bases. Even as far as the early 90s, they were trying to extract information and using NLP tools, developing NLP tools to extract information from text. And at that time, they called it knowledge bases. So if you go back and read some of the NLP papers from last 20, 30 years, you'll see that the term knowledge base is actually not that uncommon. And, so it's been around actually, especially in NLP. Now, today, there are multiple fields that are involved. So I suspect there are some of you who are coming from the semantic web side. The semantic web likes to think sometimes that it has a monopoly on knowledge graphs, which is not at all true. I, in particular, like to fight back against it, even when I attend the conferences, which is that, sure, they have formalized some of the aspects of knowledge graphs, like ontology and so on. They have made a lot of progress on that. They have models like RDF, but they don't have a monopoly. We have the NLP, as I was just saying, which has also been working on knowledge bases and knowledge-based construction for a while. Even before that, the AI community has been working on graphs for well before that. So it's a village. It's not. There's no one community, and that I hope will be a very key takeaway, because you can't, if you're only assuming the semantic web definition of a knowledge graph or only the NLP definition of a knowledge graph, then you're missing out on a very big part of the community. And to truly know the frontier, you have to look at what everyone is doing. Because we can't ignore, just because we are not from that community or this community, or we can't ignore the work that has been done in the other communities. So there are lots of people working on this concept, sometimes under different names, and so there's been a lot more progress than we would like to think, because sometimes they will cover a problem in NLP that is much better understood in the semantic web. Or sometimes in the semantic web, they will try to come up with things that are actually much better understood in NLP and data mining and some other communities. So with that, what is the 5-year frontier? Given that so much work has already happened, we already have systems for extracting knowledge graphs, for querying knowledge graphs. All of that has been applied as well as researched. So what is the 5-year frontier? I think the first, the most important thing, and something which is immediate, which is already happening, but it will take 4 to 5 years for it to truly materialize in a very big way, where it becomes commonplace. So once it becomes commonplace, that's when we know that, yes, it's here, it's done. It's not the frontier anymore. It's inside the frontier. And I think that is to broaden the scope of knowledge graphs. So here are 3 that especially excite me. I only work on one of them. Although I want to get into another one. But here are the 3 that I think are really ripe for disruption. So one of them is KGs for manufacturing. So here we are thinking about the 3D printing companies. We're thinking about Siemens, the big manufacturing companies. They collect a lot of data. They have invested a lot in IoT, Internet of Things. I think the 5G revolution is also going to be very big for them for that reason. So they have a lot of data. They are investing more and more in machine learning and robotics. And so what does it take to actually build a knowledge graph for manufacturing? Because it's a very different kind of knowledge graph, right? It's not like the web knowledge graph where you extract things from Wikipedia pages and you put them in a search engine. But this knowledge graph will be very different. It will have time series data. It will have numbers and units and time stamped entities and just a lot of data which has very unusual model of semantics than what we would normally expect a knowledge graph to have. There's KGs in legal domains. This one is exciting because the legal profession has become very complicated. More and more legal firms are actually moving to the model where they're trying to save money. So they are willing to invest in technology that will allow them to save money on legal research and finding things that are relevant. So I think there are a number of companies that are already in here. They are primarily NLP based, but I think we will start to see a lot more knowledge graphs, especially for international law firms, for some of the law firms that work in many different markets. And then KGs for health and epidemiology. This, of course, is very big right now, right? And in fact, on this point, we recently published an article where we discussed, it's kind of almost like an opinion piece, but it's more scientifically written, which is that what are the opportunities for knowledge graphs in COVID-19? And, it was really encouraging to find that when we wrote this in early 2020, by the time it got published, which was very recent, there were already 3 or 4 different big implementations that had, for COVID-19 knowledge graphs. People had released a lot of data on COVID-19. And if there's a silver lining behind this pandemic, it's really shown us that the world is ready to adopt new technology, including the web conferencing, the use of machine learning for various things. We have seen progress in education and government and all kinds of things. And I don't think we'll go back. Once this pandemic is over, some of what we had before will come back. That's what everyone is saying. Everyone can't stay isolated forever. But a lot of things that we are doing now is actually it's here to stay. Now, the other one for the 5-year frontiers, KG, is for social good. This is something that some of us are very interested in, but it's growing. It's growing. On the right-hand side, what you're seeing over here is from McKinsey. This is something that McKinsey put out in fairly recently. And what they tried to do was to figure out, all of these different AI tools, can they be applied to these domains? And to what extent can they be applied? And so if it's like a big circle, that means the application is quite big, it's higher. And I want to point you to just two things, which are, language understanding, which is, and natural language processing, which are very intimately connected to knowledge graphs, but also deep learning on structured data. Everyone here, or most people, you have probably heard the recent news that came out of DeepMind, right? Where they were able to solve a problem that many people said are decades away from being solved, which is a protein folding problem. That is an example of deep learning on structured data. But we also have deep learning on tables. We have deep learning on knowledge graphs. So there's this one. I think this is very exciting, and we will see a lot more to it. So even though you don't see the phrase knowledge graphs, the knowledge graphs are, they are very relevant to 2 or 3 different fields over here. So I think this is very exciting, and this is something where we are doing a lot of work. So what's the 10-year frontier? I think the single biggest question that we are dealing with right now as a community is that what is knowledge? So this is a problem that it's best not to get into a deep discussion about it. But I think this diagram here hopefully conveys to you why it's a complicated question, especially in this era where everyone has an opinion, and it's very difficult to separate the opinion from the facts. Right, so some people are saying we are in a post-truth era, right? And we have social media that everyone is just, sometimes you have contradictions, you have conspiracy theories, you have sarcasm, you have beliefs, you have all kinds of things. So even though this is from philosophy, I think you will recognize that there's everything from guesses to nonsense to knowledge, which is very strong knowledge, kind of like scientific knowledge. There's, there are things that are true, but people don't want to believe them. They are just pure beliefs. There's knowledge, which is kind of very fuzzy. It's very informed. You can't define it. You can't describe it. And then there's knowledge and memory, and so on. So it's a hard problem. What do we mean by knowledge? What goes into our knowledge graph? How do we qualify it? How do we reason about it? Because so far we're kind of just dealing with this portion in the middle, and a very narrow subset of that. And then the other problem is the semantics. So if you remember in the very beginning, the definition I had given was that a knowledge graph is a multi-relational directed labeled graph with semantics. But now the question is, what is semantics? What's the meaning of meaning? Again, it turns out the semantic web community has an ontology or a schema where they say that here's the ontology and the knowledge graph is defined according to the ontology. And they are really coming at it from the very structured side of the equation. But then the NLP people are saying, well, these word embeddings, the deep learning tools, they have a very different conception of semantics. And what they are saying is that a word such as quark is the meaning of this word can only be understood if you know what the context of the word is. So here we have 3 quarks from Master Mark. This is from the novel Finnegan's Wake, an unreadable novel. Quark, one of the most influential of modern Ferengi. For all those of you who are who are Star Trek fans, as I am, this is a character in Star Trek. For those of you who are physicists, quarks and have obviously a meaning in physics, but quark is also a French cheese. I'm sure there are other meanings as well. So it's not so clear that we actually get something out of a word sitting in isolation, or even a concept sitting in isolation. The context is very important. And here, this slide is from Adobe, not the slide, but the figure is from Adobe. But basically, what they are, what I think can be understood from what everyone is discussing about context is that this is a 10-year problem. To understand context, to understand semantics, to understand knowledge, these are very hard problems. And if we are able to do it, if ultimately our AI and our knowledge graphs are context aware, then we will be able to perceive at the same level as a human does. And the word perceive here should be construed very broadly, where we are able to see something or read something, and it's not just the word or the immediate impact, but we will be able to see it in its context, and we'll be able to understand it in its context, which right now we are not able to do. And then just one or two more slides, and I'll stop for questions. I know I'm running over time. But here's my 15-year frontier. And this is, I won't even try to go beyond that. And, it's not clear whether this 15-year, the longer you go out, the more uncertain things become, right? So we don't know if this 15-year is actually a 50-year frontier, or it might actually get done in 8 years. We just don't know. It's extremely uncertain where this frontier lies. But I do believe that, the conversation around artificial general intelligence is very much active. A lot of people are of the view that we are kind of now moving into this AGI era, because, the ANI, the artificial narrow intelligence, we're kind of there. We have very good tools now, the deep learning tools, the ANI, the DeepMind tool that you just saw, the protein folding, you might want to look that up, or the Go playing, AlphaGo, which can be grandmaster. I mean, those are all examples of narrow intelligence. The reason is they are very good at that one task, right? But you can't actually turn them onto other tasks, not without significant retraining, redoing. A nice story about the protein folding one, if you look deep into it, is that, it turns out that the DeepMind team actually had to work on that for 2 years. So when they first started on that problem almost 2 years ago, and the first system that they came out with for protein folding was really not that great. It was good, but it wouldn't have made the news in the way that this system just did. So they in interviews, they said that they had to go back to the drawing board a lot of times. They had to redesign the network. Then they had to train it. They had to do a lot of trial and error, and they had to do a lot of training, which they can do because they have all those resources. But basically, they had to really approach the problem from a very ANI perspective. But we're now starting to move into this field where we are looking more and more at general intelligence. What do we need to do to build an AI that can do many different things at the same time? And what will that take? And then can we even reach this point? So it's very uncertain whether we will get here or how long it will take. And then there is this thing called a singularity event. This is where I think we start moving into science fiction, but we never know, which is that, the super intelligence. Some people say, well, this is coming, but we first need to come here, and then we have to come here, right? So in order to come from ANI to AGI, there are all these things. I've just listed six different things, but there are many more that all need to be solved. So causal knowledge, the common sense, which is something we are working on. It's a 4-year program. Context, which I being context aware is a 10-year problem. But then if you want to explain our outputs based on the context and so on, and that's maybe another 5 years. How can AI adapt to novelty, something it has never seen before, not even from a distributional standpoint? How do we reason about events and time? Theory of mind, how do we reason about other people's beliefs? This is something we are very good at doing, but animals are not that good at doing. How do we get a machine to do that? So there are lots of interesting questions that have to be answered. And with knowledge graphs, these are very closely related to knowledge graphs because, if we are able to solve some of these issues, then we would need to do it for our knowledge graphs as well. So, common sense is a kind of knowledge, right? We have a lot of facts about the world in our head, and that presumably can be represented as a knowledge graph. Similarly, when we have something like causal knowledge, we can represent this as a knowledge graph, but how do we make the knowledge graph more causal, right? And so they're very tied together. So I think by the time we get here, the boundary between the knowledge graph and the general AI will have blurred. They will have become one and the same, because we need them. It's like you're not different from your memory, right? You can't really separate a lot of things that are in your brain. They kind of go together. So I think that is where the true 15-year framework lies, combining the knowledge graph with the reasoning, the actual intelligence. It all has to come together in a single architecture. So with that, maybe we have time for a few questions. But I'm happy to connect on LinkedIn with anyone who has other questions, wants to do a deep dive into this. Please do reach out to me on LinkedIn, and we can have broader discussions therein as well.
Thank you, Mayank. Thank you for your talk. We do have a couple questions, and I see some more are coming on the chat. So, Mayank, can you read the chat? Do you want to pick up the questions yourself?
Sure. So I think one question is, do McKinsey and/or others publish similar charts? So Larry, by similar, I'm assuming that you meant the hype curve, or did you mean the other one, the KGs for social good?
I think that's the hype curve. That's when you were showing the hype curve that question came.
Yeah. I don't think, I have not seen such a slide from McKinsey. I have seen it from Accenture and from Deloitte. I think Accenture and Deloitte definitely come out with, I haven't seen a curve from them. I have seen them say, okay, what are the top technology trends? I think if I'm remembering correctly, either from Accenture or Deloitte or both, I know that they come out with technology trends, and I have some of them on my machine. But I don't really see a height curve as such that they have come out with. I think Gartner has really, if anyone else tries to come out with that, it would probably look like they are imitating Gartner, and I'm not sure that that's very flattering. So I haven't seen a curve like that from anyone except Gartner.